treatment. Okay. And then I have observations are independent. So
Yes. Independence is very important.
Independence. And that's with independence with each data point in a set or between each set.
Yeah, there's kind of these columns. Most of the time it's done in columns, and you like it's yeah, I think we talked about like airlines, but it could be whatever the things that you're comparing, that's your sample of data.
Yes. The entire, like both, like everything.
Well,
each line of comparison would like independent from each, like let's say you have like it's like block 1, 2, and 3.
Yes.
And block 1, 2, and 3 are made up of like ABC, ABC, ABC. Does 1 have to be independent from 2 and 3?
Yes.
Does within 1 the data points have to be independent of each other?
You're sampling like something that's always the same. Like maybe it's gas prices.
Yeah.
So like these are different gas stations that you're going to, but 1 is in the Philadelphia area, 2 is in Phoenix, and 3 is in Chicago maybe. But
okay,
are they independent? I mean, I guess they are. They're I mean, you're sampling different data points, they're random, but it's between the treatments, between the groups.
Got it.
At
Okay.
the independence.
That makes sense. And then yeah, I have the normally distributed.
The errors, the residuals.
Yes. Oh, okay. On my slide, I have basically yes. How do we verify that the observations are normally distributed? But then it's by analyzing the residuals. So I'm assuming the residuals are normally distributed.
That's correct. That's that whole plus epsilon IID normally distributed.
Distributed residuals. Okay. Cool. That makes sense. Okay, and then the table.
Yeah. So that was those 10 questions you're mentioning.
Yes.
Are you comfortable finding or doing the calculations, given missing values to back, kind of backfill the ones that are.
Could we go over that again? I feel like that's where on this exam I'm like least comfortable with.
Okay, let me see if I can find a problem real quick for this. Okay, this is your classic exam question here. Let's see if I can. All right. So notice that like it doesn't tell you, like in your problem, it said it was like something to do with potassium. Sometimes it just says treatments.
Okay.
Now I have to give you something here for us. No, actually I do not. There's actually enough information here to do everything. So they're helping you out here by telling you that the mean square is SS divided by degrees of freedom. You probably would not be given that information. So you need to know that to find the degrees of freedom, you take this number and you divide it by this number.
Okay. To get the total degrees of freedom.
The treatments.
Or okay.
So I'll color code this here so that you can look back later, but find this number right here. It's 2.124 divided by 0.708.
Well, would it? Yeah.
Now there's another way that you could do it. Like you could be given a prompt where it says that, for example, that there were 3 groups, 8 each. And that tells you the total number. N times K is the total number. 8 times 3, which is 24. And your total is always big N minus 1.
1.
And if I told you that was 23, you could then subtract 20 to get the 3.
Got it.
Okay.
Okay. Yes.
All right. Now this is, you might think, okay, well, I got it now. I'm really good, but they don't give you this number here, SS error. So you can't find the mean square for the error.
But we can find it through the F statistic.
That's right. That's right.
Right. Because it would it be those two multiplied together?
It's SST over SSE.
So
Or I'm sorry, it's MST over MSE. So mean square of the treatment is the top number
yes.
and MSE is the unknown number.
Oh, so it would be like actually I'm so bad at doing mental math that
Well, this one's pretty tough here. Like this would be think of that as X right there. You have to switch positions or swap here between the two.
Yeah, so 0.708 over 0.75.
Yes, and that ends up being 0.944.
Okay, got that. And then
to find the blue.
so S.
Seems like you might have a question, so let me know.
Yeah, this, like I had never seen this, kind of screwed me over on the last test. I had never seen like SSC and SSR and all those things, so
right,
I'm like so unfamiliar with it.
So the SS is the sum of squares, and that last letter is for the treatment, which is the regression in that type of problem. That's SSR.
Got it.
The error is the error.
SSC.
But in terms of this calculation here, it comes from, and say I'm gonna be careful. I don't want you to like remember all the variations of this formula, but maybe since it's open note, that would be okay. So I'll write those down here for the so you have a couple of possibilities. MS equals SS divided by degrees of freedom, or SS equals MS times degrees of freedom. I think those might be worth remembering.
Got it. Yes, but then how do you get like from SS to SSE? So because you find the total.
We don't have the total yet. We're gonna find this blue. That's what I was trying to get you to do. So
Okay.
So with this formula here, you take the mean square times the degrees of freedom. So you're gonna, for the blue here, it's 20, 0.944 times 20.
Wait, how do we get 0.944?
From the F statistic calculation.
Oh, and that's how you get the SSC.
Yes. This is going to give you SSC, which is 18.88.
Got it.
Now to get the total,
So it's MSE.
Get the total here, you add the two together, the 2.124 plus the 18.880.
Yes. Okay. That I understand now.
Okay. Now there's a bit more to this that we saw in the let me go back to the problem in your practice exam.
Okay.
Because there was another little thing that it asked you to calculate. Just make sure let's let it load up here. All right, so you were asked, let me grab all this. You were asked to find the standard error of mu0, which we decided was the square root or the root mean square of MSE.
Yes.
This one right here. And we're like, well, how do you get that? It literally is the square root of this number right there
MSC.
of MSC. Yes.
And to find MSC, it's root of, well, MSC is SSC over degrees of freedom.
Yes. Exactly.
Okay. Yes, that
Yes.
I have.
Okay.
That I understand. Okay.
Great.
Cool.
Okay, so let me reset here this list. It took me a while earlier when you said jump. I finally realized you meant JMP.
Yeah.
It took me like, what is she? Okay.
Yeah.
Yeah.
No, that's like, I don't know. That's what it's always been referred to as.
Yeah. And so that, like, you will be given some sort of a JMP output or jump output,
Yes.
and you have to, and like, I'm sure that the teacher will omit certain things here, but like, here's a,
I think it'll be very similar to like the ANOVA table situation.
it is. I mean,
Yeah.
it is an ANOVA table, and then notice, see how they give you the T and they give you this standard error.
Yeah.
That's where I was wondering like why these weren't in there, and that notice there's a P value. Like, the one thing down here that might be worth noting is that the T is equal to the estimate divided by the standard error in each row.
Oh,
Yeah.
Okay.
That might be worth noting. You've got the R square. I'm sorry, you got the root mean square. You got some other stuff. I mean, you just have to know how to interpret this table, and
Yeah.
maybe be able to calculate some values in there.
And okay, wait, I'm just like making sure I understand each. Yeah, I think I get.
You
all of it.
rarely use this R square adjusted. You generally just use R
Yeah.
square. We talked about how to calculate the root mean square.
Yeah.
The mean of the response is the global mean. Total observations, that's your big N. This is N minus 1.
Minus 1.
This is K, and then the first one is N minus K minus 1.
Got it. And wait, how did K is the, wait, 1, 2, 3, 4, 5, 6. Got it. The number of
In this case, the P34, P58, each of those are the intercept doesn't count as a level. These are the levels, or the treatments, depending on how you're doing it.
Like in that case, like 14 minus, wait, N is
15.
15, K is 6.
Yes.
So
I'm sorry, it's N minus K in the for that one, and then this is not right. There it's N minus. I got this wrong. Give me a moment here. The model is just K. That's the mistake I've made.
Oh, got it.
And it is correct back here in this one we did. We said that this was K, 3 treatments, N minus K, or N minus 1 minus K.
Got it. Yes. Okay. That makes sense now. Okay.
Okay, so the next one is the multiple comparison. Part D here.
Yeah.
We talked a little bit about this last night. It was like one was better for a where you compare each of your levels one at a time, and then the other one was better if you kind of had an idea of which direction to go in.
Yeah, I'm gonna ask about that tomorrow. Like what exactly I'm gonna need to know about Tukey and Bonferroni.
Yes.
Because no clue what like is gonna be tested on that.
I mean, if you ever wanted to, you could always send over like 26.3. We could always kind of go into that, but it's going to be up to you. The model verification using residual plots. So we talked about that the residual plots have to be normally distributed.
And so is that like within ANOVA, is that looking at the QQ plot?
You have more than one. So no, it's not,
Oh, I remember this in class actually.
okay.
Just making sure there's not like a skew to them.
Yes.
Got it. Okay. I think that all clicks.
Okay. That is everything from
Yes.
stats.
Okay.
Any other questions or things from that you want? Do you any other like maybe old homework or something from notes we should go through or anything like that?
Let me double check. I think that might be it. Oh, okay. Well, so I know how because we did this in class, but if you could maybe explain why. So I have there was one question on a PowerPoint that said, consider the multiple regression model with k equal to 7. How many population parameters do you need to estimate and what are they? In your count, include the standard deviation of the error terms as well. And so my professor said, add 2 because B not
That's right.
and the population parameter add. And so if like k equals 7, then it would be 9.
So with my concern here is what is the other one? Obviously you got 7 here for these.
And the
Does he do the error term?
error term and include the standard deviation of the error term as well.
Okay, so that's how he's getting to the +2. So this is the intercept and then the error term.
Yeah. Okay. And you just are estimating.
So the error term is always mean 0 and sigma squared. So the way I interpret your notes is the standard error is the sigma.
Yes. Okay. That I understand. Okay.
When is your exam on this class or in this class?
The Monday.
Monday. Okay.
Yeah.
And you said you have at least one more class between now and then.
Yeah. So I have class tomorrow.
Okay.
And then I'm seeing him after class to ask questions.
Okay.
So I will do that.
Right.
But actually I feel like I feel pretty confident now.
Yeah. No, I mean, talking it out like this is really, really important.
Yes. But then okay, so I also have an econ exam on next Wednesday.
Okay.
And I don't know, I know like econ is math, but not really.
Some of it is. But I can't help though. I've helped a lot of econ over the years, but
Yeah.
it's hopefully it's not as odd as this. Hopefully it's more straightforward.
I think it hopefully will be. My professor's an Italian guy, so I don't know. There's definitely still a little bit of miscommunication, but in the attachments that I had originally sent you,
Yes.
let me actually see if it would be. I guess so. He put for each topic questions with answers of like just the topics individually. There's also practice exams that are like very similar to what the actual exams are. I don't know where I think is a better place to start. Maybe with just the individual questions.
Is that like from like a lecture 4 or the questions for students
So
productivity?
questions for students productivity, no solution, and then a question for student productivity, that's the solution document.
Okay. So you're saying like what you sent is with and without the solutions? Is that
Yes.
what I'm
Yeah.
saying? Okay.
So I
Which
feel like
one?
maybe that would be a good place to start.
Is this like a intro economics or a medium
It's
economics
an
class?
intro.
Okay, all right.
I don't really understand how it's intro, and I feel like that gives me such imposter syndrome because I'm like, how am I actually so confused? But then I like realize that the course is actually not really intro.
Yeah, I would say it's not based on what I'm saying. Um, all right. It's good that the solution's are here because this will help me explain it.
Yeah.
Um,
I just like, I'll be honest, do not always go to this class. And it's like a 200-person lecture with a guy who I can barely understand. So I'm like a little lost when it comes
okay.
to
Okay. Well,
econ. I did take macro in high school, but it's not this stuff.
it is not. I will gently encourage you to always go to class, even if you're not. Um,
Well, yeah,
it
now like I'm going.
Yeah, like, and there's no
At the
judgment here. I mean, I was a college student at one time, and I know what it's like. I will just say that it's if you can, even if you're not fully present, it's better to be there physically rather than to
Yes,
not be
I
there at
know. In
all.
the past, like 2 weeks or before, like the past month, I've been consistently going, but productivity was the first kind of unit we did. And I probably went like 60-70% of the time.
Okay.
So um I'm like a bit lost.
Yeah. Okay. Well,
Um
I'll try my best here. Do we want to start with exercise one here or go to something different?
I feel like maybe just start with exercise 1.
Okay. Fair enough here.
Let me get my notes already. Sorry. Um,
Let me know when we're ready here.
sounds good. I'm trying to just pull things up on my iPad. Class. Yeah, that has not been written in. Okay. Okay. I am good.
Okay, so the Cobb-Douglas production function is this y equals a times k. I'm just rewriting what's given, L to the 1 or alpha, L to the 1 minus alpha. Now what's not made clear here, and I'll make that clear, is y is really a function of two variables, k and L.
Yes.
Okay, and that's kind of important here because you may not be used to seeing functions of more than one variable. A is a constant. They don't say that, but it's a constant. Alpha is a number, which you'll get at some point. All right, so here's how you proceed. They say to constant returns to scale. So you take k. All right, this k becomes c times k, and L becomes c times L. So what you're really finding now is y of c times k, comma c times L.
Okay.
And it looks really complicated, mostly because there's a lot of letters, no numbers, but you are now just substituting in CK wherever you see a K and CL wherever you see an L.
Got it. Okay. Oh, because okay, because I got it.
Like that.
Got it.
Now, the next thing here is to apply the exponent rules. All right, so this alpha basically gets distributed to the K and the C. So it's A still there, C alpha, K alpha, C1 minus alpha, L1 minus alpha.
Yes.
And then if you recall your exponent rules, let me just rearrange this slightly. You put it where the C's are next to each other.
And like, got it.
The exponent rule is if the bases are the same, you can add the exponents. So this becomes C to the power of 1. So actually, let me move this around a little bit more. I'm going to put A here. So it's C to the power of 1, K alpha L 1 minus alpha. And this part here that I'm sort of grouping together, that is your Y. That's what you started with.
Oh, yeah.
And that's what it means by constant returns of scales. If you put C in for both of these, you get C times Y, which is the constant returns to scale.
Got it. And okay, I have like the notes I have if for constant returns to scale, if increasing all the inputs by a certain amount, then we observe that also the output increases by that amount. Got it, because it's
should.
the constant and your got it.
Yeah,
Okay.
so if you made like C2 and this other C3, you would not see a return. It would be bigger than that, but that's not what it's asking for here. It's
Got
just
it.
asking you to do this. Okay, so part B. Part B is for the same function. This is why I was asking if this was really a intro econ course, because this is a medium level econ, most other universities. So
Yeah.
it says give an example with different coefficients for K and L such that the function is not returns to scale. So the answer leads us to how we're going to show this. I wouldn't have known this without seeing the answer. If the coefficients did not add up to 1. Again, this is kind of one of those weird English things. It's interesting you mentioned it's in Italian. This is not good English. Even I know that.
Yeah.
All right. So
Yeah, I know. In like my two most difficult classes, I have an Indian guy with a thick accent and an Italian guy with a thick accent. So
yes, very tough, very tough. So we just need to if we wanted to do this, we would have to do the same thing. We'd have to do f of, and I'll just pick 0.4 K and comma 0.8 L. And you do the same thing. You put these into that function. So it's A 0.4, sorry, K to the alpha, 0.8 L to the 1 minus alpha. And then you do distribute that alpha. So it's 0.4 alpha, K to the alpha, 0.8 to the 1 minus alpha, L to the 1 minus alpha. And what you find is that this part and this part do not get you to the C. Like if you picked a value of alpha, you will see that. Like so you just have to show that it doesn't work.
okay,
Assuming you don't get a calculator in this class.
we do.
Oh, you do. Okay, so
This
you could
one's
actually
also open note.
okay, so you could, for example, let alpha equal 0.5 and actually show that 0.4 to the 0.5, 0.8 to the 1 minus 0.5. This does not equal 0.4 plus 0.8.
Okay. And so talking in like applicable terms, like K is physical capital.
I don't remember.
Because I'm just like K is like an amount. It's like also a number that would be put in.
Yes.
Yeah.
Yes.
Okay.
Sorry. Yes. That is correct.
And then
you're dividing you're dividing up your resources between capital and labor, I think, maybe.
yes.
And
Yeah.
there's like this relationship between them where you can only get so much of one versus another.
Okay. Oh, and so that's like what Cobb-Douglas is saying.
Yes.
Okay. This is starting to make sense.
Yes.
Okay.
All right. So like the next problem C is more numerical. And we'll look at that here now. Now suppose all the population works and that the per capita capital is 4. And I believe, so that is referring to,
The physical capital over labor.
yeah, so that 4 is K divided by L is what it looks like according to the,
Yes.
is 4, okay? And alpha is 0.5. So there's a few ways that you can do this, okay? So the way that the solution shows is you take the Y that you've been using, the A, K to the alpha, L to the 1 minus alpha, and you divide it by L.
Okay.
And when you divide it by L, you have to remember these exponent rules here. You take 1 minus alpha, subtract 1, and you get minus alpha, which puts L. Basically, it puts you end up, sorry, I'm doing too much talking. This right here becomes L to the minus alpha, which is 1 over L to the alpha. And you're putting that on the bottom. So it ends up being AK over L to the power of alpha because you can group them together.
Got it. And so how would I know to make it all over L? Oh, because it's per capita. How
I don't,
do I turn the original Cobb Cobb-Douglas?
yes. I'm not sure. This is the extent, like I'm going to be helpful here to explain the equations.
Yeah.
I don't know why it's Y over L. It's probably a very simple thing like you're saying, but I really have no idea.
I think okay, wait, yeah, it would make sense if it was per capita because then it would be basically Y is GDP like output. So output
That makes
over
sense. Yeah, over the labor.
labor.
Yeah, that sounds, I mean, that's what per capita is. I mean, that's
per capita. Okay. And so then you're just kind of plugging and chugging the numbers.
yeah, they tell you that it's K over L is 4, and then A must be given in, they tell you that A is 3, it looks like.
Yes.
So you've got now this is kind of an aside here, but they generally, that's why I asked you if you use a calculator or not. They generally give you numbers that work out really nicely. Like if you're gonna take 0.5, it's gonna be the square root of something you know, which is 4. And that becomes 6. Not always, but that's another.
Okay. Yeah. That
All right.
actually makes sense.
Okay.
Okay, this is actually not as complicated as I tend to look at things and if it's like a lot, I'm like, okay, no. But this is not bad.
Yeah. And don't hear this as a parent right now. I'm about to say, but you have to learn how as a student to work through these classes, meaning like you either rewrite your notes or you re-listen to the lectures, or you have to find the path for you, or you recognize, hey, like there's a reason I'm in this class. It's not impossible for me to do.
Yeah.
Okay. So it says here, what happens if the per capita capital rose by a factor of 3? Okay, so what do you take that to mean?
That if the row if and the total if the total fact per capita capital rose and the total factor productivity decreased.
So let's just take it one clause at a time here. So in the previous problem, we said that K over L was 4, but now it says that it rose by a factor of 3. What does that mean here? To either the left side or the right side? What does that tell you?
I would multiply by 3.
Yes, so you're multiplying that by 3 and that by 3. Okay.
Yes.
All right. Now the next thing here is that the total factor productivity decreased by a factor of 3. Okay, so that the fact that it's a factor means that you're dividing. So A was 3, and now
And
you're,
that's 1.
yes. So you're going to use the same y over L relationship, which we know simplified from, unless you want to redo the calculation, it becomes this, but your new A, so your new A is 1. I don't know how you want to denote that. And your new K over L is 12.
Okay, because it's 4 times 3, and then you'd put that to the still.
Yes. Yes.
Got it.
And that's whatever it is, 3.5.
Okay. Wow. This is like, okay, this will be doable. I kind of was like, okay, let's start with stats because I can like actually understand it. But no, this I can learn by Wednesday, I think.
Okay. Well, it's doable here.
Okay.
Right.
Yeah.
They're constant. So actually we should have done exercise 2A earlier, but that's okay. We'll do it. It's related to part A that we just did. So we'll move on to that now. For each of the following production functions, figure out whether they are constant returns to scale or not. So y is really a function of L and K, and it's L plus 9K still. And the answer to this is like you can use a constant again, like we've been doing. You can change L to being CL and K to CK. So CL plus 9CK, and that becomes sorry, CL plus 9CK. And then you can
And so it's not because.
wait, you can factor it out though. You factor out a C.
Oh.
And then if this is the original, it is return to scale.
It is
Yes.
constant.
Yes.
L. Oh. Oh, got it. Got it. So you just like algebra, work it around, and if
exactly.
It's okay, got this.
And so the next one, one of the things you should notice is whether I don't want to say this. See how the exponents don't add up to 1?
Yeah.
That's a pretty good indicator that it will not do a return to scale. But we got to show the work here again.
Got it.
So your answer key uses T instead of C, but I think C is more clear.
Yeah.
So we're gonna do that again here. L comma K. So we're gonna go C times L, C times K. 1/4 C times L, C times K squared. Is that okay? Is that clear?
Yes.
So it's 1/4 C times L, C squared, K squared, like that. And then you don't need the parentheses anymore. You can combine the C's. So it's 1/4 C cubed, L times K squared. And then
because if you wait, how can you? Oh, because you don't need the parentheses.
You don't need the parentheses. Yeah, you're not factoring out this time.
Got it.
And then if I just move this 1/4, that actually didn't look very good. Let's not do that. If you rewrite it here with the 1/4, you're always trying to get back to your original Y and basically seeing like, what is it on the outside? If it's just C, it's constant return to scales. If it's anything but that, it's not. It's cube return to scales.
So, okay. Got it.
All right.
So if it was like, but if it's just C, then yeah,
constant return to scales.
If not, okay.
And
can you tell from this if it's increasing or decreasing return to scales?
This is increasing because
the exponent is greater than 1.
Yeah. And the other way, the more simple way, I guess, is to see that you only start out with C and you got C cubed back, which is
Got
really
it.
good, really good.
Okay.
Return.
Very cool.
So I think the whole point of Cobb-Douglas is that if the exponents add up to 1, you get constant returns to scales. I think that
Okay.
was the big deal with him.
Yeah.
And we kind of already did this, but we can do one more.
Yeah.
So C times L, C times K, C times L to the 1/4 power, C times K to the 3/4 power. You apply that exponent to both variables. And then you combine the constants. So you get C to the power of 1 because you add the exponents.
And then
that's
L to the 1/4. That's cool. Okay.
yeah, it's kind of it's a really important property of this.
Yeah. Okay. I understand that.
Fantastic.
Okay.
All right. So that's only part A for exercise 2. Part B is a little bit more involved, but I got to say that having the solutions here is really helpful for me because I can quickly look at them and then try to explain them in a meaningful way.
This teacher is far more organized
I could tell.
than the other one.
Yeah. So we already know the answer to this. The question is though, is it good enough to just sit here and say that A equals 6/10 because 6/10 plus 4/10 equals 1? That's probably not the case. You probably can't just do that. In fact, the solution shows that you can't do that, but
I will say the actual test, although I would like to go through it because who knows what we'll ask, but this test will be 30 multiple choice questions.
okay. So the quick explanation is that the exponents, because it's 2 factors and the exponents have to add up to 1, that's Cobb-Douglas.
Yeah.
To show it, you have to actually do the same thing we've been doing, and it's got some algebra in there. Maybe we hold off on doing that but it's up to you. We can definitely show it here if you would like.
Well, is it just like the same thing?
Yeah. Yes, but
Okay.
it's a little bit more intense algebra because you have to show.
Yeah. Then I think like it's fine. Because like I understand the concept.
Okay.
That. So then.
All right. So move to exercise 3.
Yes, sounds good.
Okay. All right, it says consider an economy that generates output according to the following production function. So whenever you see this K and L, you want to think Cobb-Douglas. Y designates output, K and L, capital and labor. That's what I was looking for earlier. That's good. No other inputs are used in the production process, so on and so on. Okay, so the first question is, and we've already kind of answered this, is for what values of alpha, and that's this one up here. That's
Got it.
different typeset. Constant returns to scale. So we've done this.
So 3/4.
3/4. Okay.
And then anything greater than 3/4.
Yes.
Would be increasing returns to scale.
Yes. Yes. That's exactly what the solutions say. They say alpha greater than 3/4 increasing. And then the other way, alpha less than 3/4 decreasing.
Okay. That's easy enough.
Yeah. You see that they're very repetitive here.
Yeah.
All right, part B. Part B here. Here we go. Part B. It says ignoring the answer to the previous question, consider the case where A equals 10, alpha equals 0.75, K equals 256, L equals 10,000. This is a problem where they're giving you, I believe, all of all of the
Yeah.
values here, and you have to just simply use your calculator to be able to do
What
that too.
is
Are you using like a TI-84, something like that?
Yes, exactly.
And then 10 here. So just you have to be able to do that calculation, whatever that comes out to. It ends up being 64. This one could be done by hand, which is why I was asking about your calculator. But
Yeah,
I'm glad
no,
you
it
used one.
is. Yeah, both both of these exams, both stats and econ, are open note calculator.
Great.
Everything, which is nice. Did
All
not
right.
help me on my last exams in these classes though. So
There's actually a study put out, I think it might have been Harvard. The professor, he gave like 2 or 3 hours for the exam, and the first 2 hours was like no notes, no calculator, and then he would open it up, and he found that the grades didn't change. So that's why he opened it up to notes and calculators.
yeah.
But okay, last problem for us for tonight here. Now consider the effects of increasing the quantity of labor if labor is increased by 5,000. So basically they're saying L went from 10,000 to 15,000. What level of production is reached? So you've got to do a new calculation for this, where you're just changing that L to 15,000. It shows that that is 70.85.
Yes.
So that's part A. And then I think the second one's more difficult here. It says if labor had remained at 10,000, how much additional capital would be necessary to achieve the same effect? So what they're saying is we want Y to be 70.85, but this time you don't know K. You just know that it's K to the 3/4 and it's 10,000 to the 1/4 over 10. Now, since this will be a multiple choice test, you would want to try the answers rather than solving
Yeah.
this. Typically would be probably a little faster.
Yeah,
Right.
but that's just like algebraic manipulation.
Yes,
And then
yes, yes.
Okay.
So unfortunately, as much as I'm enjoying this here, we do have to